Okay, everybody. This is the basically pre-final exam that you're going to have. This is the heart rate data that we collected from class. If you don't, or not sure of what it was, then please check. Anyway, so talk with somebody from class. What I'm going to do first is we're going to calculate a few variables so we can do the analysis. This data will be saved in the iDrive, so you don't really have to do this. But I just want to show you what I'm doing. So first thing I'm going to do is going to average your first and second heart rate, transform, and I'm going to compute, and then HR1 average, okay, and that's going to be your first resting heart rate. Oops, sorry. Parentheses heart rate HR1. This is an exciting video when I keep making mistakes. Plus second resting heart rate. And then I'm going to divide that by 2. Add them up, divide by the number. Hit OK. And then I'm going to do the same thing. Transform, compute. I'm going to HR2 average. Okay, and this is going to be, get rid of those. Okay, so I'm going to take second resting heart rate plus second resting heart rate. Oops, sorry. I'm going to take heart rate after walk minus or plus. Man, this is really exciting. Heart rate there. So this is the after walk heart rate. By 2. Okay, so I did that, and now I'm going to transform. I'm going to compute change. Heart rate change. Okay, so this is going to be heart rate 2. The average for after the walk minus the average for the walk, before the walk. So we calculate, okay, heart rate change. So far so good. So now, now that I have my calculated variables, there they are, what this number means, this number represents the amount of change that the heart rate has gone under. You could also, let's also calculate, yeah, that's fine. Okay, you could also calculate other change variables if you want to, but not necessarily a big difference. So the first thing that we have to do is you have to look for power analysis. So let's check our groups. So we're going to go look and make some big pie charts. We could do crosstabs if we wanted to, but we can just look at the pie charts and see. Let's see if we have equal groups. Percentage of cases, let's do n. And we got, oh, it's almost as if it's randomly distributed. Thank you, random number generator. Woohoo! Yay. Okay, sorry. Let's look at male and females. This is the problem in psychology. But we will look at this. Okay, and then we have, oh, actually that's really impressive for a psych class. But that's good. Good power analysis for male and female. Let's look at caffeine. Oh, let's look at workout first. And we have, that's not too bad. We've got a nice mix of variables, 14, 15, good. That's acceptable. A little bit heavy on the moderate. Redundant, sorry. Okay, so we go back to pie charts. And the reason I'm doing this is so that I can just understand what my data looks like. Let's look at caffeine usage. So this, let's look at the numbers here. So I would say we should recode this into a dichotomous variable to yes versus no. Or we could do maybe moderate and heavy mixed together. Or just leave it as it is. We're going to recode, transform. Let's recode these into different variables. And we're going to do caffeine. Caffeine code. Or caffeine recode. So we're just going to say use caffeine or not. So the value of 0, hold on, clicking my little box, and hit caffeine, 1. So let's put 1 and 2 together, and then 3 and 4 together. How about 1, 2, and 3 and 4? All right. So we're going to go to old new values, and then so a 1 equals a 1, add a 2 equals a 2, add, and a 3 through 4 equals 3. And we might not use this, but it's good to use. Continue. Okay, change. Okay, so let me make that graph now, my new variable, and we'll label it in a second. Sorry, my caffeine hasn't hit in yet, so this is a little bit boring. I'll start dancing in a minute, I promise. So here we go. Much better. So then we have 27, 11, and 19. Better sample size. This is a little bit weak, but maybe we should have a 5-point scale. Oh well, so we could do caffeine and no caffeine. If you really wanted to recode it, you just add this group into that group. But you don't need to. Okay. Second thing, let's label that variable. Go back to my variable view and go to caffeine recode. 1 is none, 2 is light, 3 is moderate and heavy use. Okay, cool. All right. So now we have that done. I have an email. Then we go to let's look at our primary hypothesis. Does taking the stairs affect your heart rate? So we're going to do there's 2 groups. We need to do a t-test, compare means, independent sample t-tests. Okay, and before I go on, I want to make sure what I know what my groups are. 1 and 2. Cool. Okay, so group goes down to the grouping variable, define groups, 1 and 2. Continue. And then let's just dump everything else in there. Putting all my continuous variables in there. Exciting. Go. Yay. Isn't that wonderful? Okay, so we're going to scroll down and look, and there's a significant effect of heart rate. No. Oh, there is a significant effect of heart rate change. All right. Significant effect of heart rate change. Okay, there's no difference in the actual heart rates. Close for heart rate 30 seconds after walk, but the difference is in heart rate change. So let's make the graph. Reset. And then heart rate change. Oops, sorry. And group. Does taking the stairs make a difference? Yes, there's a greater heart rate change if you took the stairs than taking the elevator. Okay, it's really not that exciting. Okay, but you can write it down, and we'll talk about how to write it down here shortly. I'm going to stop and record. Second thing later. Okay, next is you go to, let's go look at some of the other variables. So we're going to go and correlate by correlation. And so I'm going to hit reset, and I'm going to put in the group. Well, we know what the group effects are, so let's put in the heart rate change, all the heart rate variables first. And then we're going to put in group, age, sex, workout, caffeine, and caffeine recode. So we roll down. Yes, your heart rate is related to your heart rate. So we're going to scroll down, ignore the heart rate variables, and look down here. Nothing. There is a significant difference in caffeine and heart rate 30 seconds after walk. And heart rate 1 minute after walk, there's a much stronger effect of caffeine. So those are things to definitely look at. Workout, there's a significant difference in these 2 things. And they seem to be almost the same numbers. So we have to go look at no differences in male and female, no differences in age, no differences really in group. So what we have to do is we have to go through and look at these. Okay, so caffeine and workout. So let's just real quick see if more people drink caffeine. Ooh, don't mind if I do. Okay, people drink caffeine who they work out. In order to do a comparison of the number of people who drink caffeine and work out, we're going to go to crosstabs. I'm going to put caffeine on the one side because I like it, and workout on the other side because I like it. and then display clustered bar charts and statistics, chi-squared, continue, okay, and we find out that, oh, there is a significant difference. And let's roll down and look at it and see, oh wow, workout. Moderate workouts are more heavy caffeine use. No people use them, none uses the most. That's funny. So the no moderate people are the people who use the most, least moderate. I don't know what I just said. Okay, but it's funny. Workout heavy caffeine people who work out a lot don't have any heavy caffeine use. So the moderate workout people seem to be where the majority of this is. Well, the majority of the people anyway, but it's statistically different. Let's do the caffeine recode just to lessen the groups a little bit. So I'm going to put caffeine over here and caffeine recode and see if this makes a better chart. This definitely makes a better chart. So when you look at the none, light, moderate to heavy, people who use the most caffeine are also the moderate workouts and the none. Notice the statistical significant differences are gone. So basically, the only difference is that the people who use heavy caffeine are also the moderate workout people. So let's look at the effects on our variables. So let's go, let's use the caffeine recode because that was statistically significant on the correlation chart, and workout. So we can do both of these at the same time, or we can do them individually. Let's do them individually because that's what we practice in class. We're going to do one-way ANOVA because there's 3 levels. Okay, I'm going to change workout to reset. I'm going to put my workout variable in here first. Because it has 4 levels, we're going to go to 2 keys. I'm sorry, 3 levels. And then all the heart rate variables. Excellent. Go. And we can see that there's a significant effect of heart rate after 30 seconds and heart rate after 1 minute. That's the much larger effect. And there's also heart rate average of heart rate 2, so that's significant. That's the same as this. But the change is not statistically significant. Heart rate change isn't significant for working out. Heart rate change was significant for taking the stairs, but it's not for working out. So we'll roll down to the next one, and let's do this next one here. We'll make the graphs shortly. Compare means, one-way ANOVA, workout, caffeine recode. 3 levels again, so we need to make sure the postdocs are checked. Continue. Okay. Caffeine recode, significant effect of heart rate 1 minute after walk, and also significant heart rate change for caffeine. So in this particular case, we're really focused on the change in heart rate. So let's make the graph on that, because that's one that's really interesting. We can look down at the t-test, and we're looking at heart rate change, this variable. None in light is not, but none in moderate and heavy is statistically significant. Light, move out of the way, double click. SPSS. Okay, light and moderate is not different. So moderate and none seems to be the difference. So we make the graph. Okay, simple. And we're going to look at reset. And we're going to look at the caffeine recode. And we're going to look at change. Because that was the one that showed the most interesting effects based on our study. So we can see that as caffeine use tends to increase, heart rate change tends to increase. So the biggest question I have, let's make the graph of workout. And then we'll do the same thing for workout, that showed the same, actually the heart rate one out. Let's make the graph for workout and see if that looks different. So in workout you can actually see that it goes the opposite way. So caffeine causes the higher change, workout seems to cause less change. Wow. Do either of these things interact with stairs? This is something new. We're not expecting you to do this, but just so you can see it, we're going to do what's called a univariate analysis of variance. Reset. Okay, like you can see what I was doing, because let's look at heart rate change, and let's look at group by caffeine. So does the group interact with caffeine? Post hoc tests for caffeine, because there's 3 levels. And we see that there's significant effective group, but it doesn't interact with caffeine. I'll explain that in a few minutes. In other words, the same effect of caffeine is found along the different levels of group. We can do the same thing the other way. Compare linear model, get rid of caffeine, add working out, and hit OK. And we can find that group again makes a difference, a bigger difference than working out. Not statistically significant. Group is still statistically significant. So taking the stairs affects your heart rate more than the other thing. The only other thing we have to roll up and look at, and we're almost done, is this one, the heart rate 2 average. So let's look at the heart rate 2 averages. The heart rate 1 minute after walk actually is a stronger effect. So let's look at the heart rate 1 minute after walk. So let's go back and make the graphs on that. And then define, and we're going to change to the one that is statistically significant. And let's look at the people who work out 1 minute after walk. Oh, the heart rate 1 minute after walk, moderate and heavy workout people have significantly lower heart rate. And then we can do the same thing for caffeine. I'm going to guess that it's the opposite. Seems to be the opposite, except for these people. But see, the direction goes up this way. The direction goes down this way. So working out seems to affect your resting heart rate after you sit down for a minute after your workout. I mean, after your little walk. Let's see if it interacts. Last one. Does it interact with whether you take the stairs or not? This is very exciting, ladies and gentlemen. I haven't done this analysis yet. We need 2 keys for workout because it's got 3 levels. And workout makes a bigger difference in heart rate after 1 than taking the stairs. So if you work out, you get the benefits of working out. We'll just make the graph. We just saw the graph. But no is different than, no is different than yes. All right, I'm going to record this and post it, and then the second one I'm going to talk about how to go through the outputs.